So for your assignment 50 tonight, it's just going to be a review of doing a Desmos picture. It's the same thing we have been doing. It's piecewise functions because you have to write an equation for each line and the if part, which is the domain restriction. So just to review, I want to number these all the same way so that everybody's number 1, number 5, number 8 are all the same, so it's easier for us to check and work together on these. So start by numbering the lines, just 1 through 15. Just go down the line there. And then I'll number the lines on the graph, and you'll copy those down so that everybody's is the same. 12, 13, 14, and 15. Okay. So I'm going to group the horizontal lines together, the vertical lines together, and then the diagonals together. So it's a same type of line all grouped together. So first the horizontals. Let's start with this one here. Let's call that 1. Let's do the two arms here, 2 and 3. Okay. And there's 2 more horizontals above. So let's call those 4 and 5. So all the horizontals are going to be 1 through 5. Okay. Next, let's do the verticals. So let's call these 2 verticals 6 and 7. And let's call the other 2 verticals down at the bottom 8 and 9. Of course, verticals are x equals, right? Vertical lines. And you'll have to do a range with verticals because it's x equals you can't do on the if part, you have to do a range, and I'll cover that in a minute. Let's see here. And then now the diagonals. So let's do these 2 diagonals together. The 2 sides, call those 10 and 11. Okay. And let's call this 12 and this 13. I'm going across because these will have the same slope. They'll just have different y-intercepts. And then the last 2 that have the same slope, 14 and 15. Okay. So as I mentioned, 1 through 5 are horizontals. Okay. All those are horizontals. So something like line 1 would be y equals 1. Okay, these are usually the easiest ones because there's no slope to figure out. And the restriction, we're going to use domain, so you got to look at the x. So this line right here starts at 1 and it goes to 12. So everything between 1 and 12. So we'll put everything between 1 and 12. Zoom out so you can see everything. There we go. Right. Now for the vertical lines, 6, 7, 8, and 9. Right, those are all vertical lines, so those are going to be x equals. Vertical lines, you recall, are x equals. So 6 will be x equals 3. But we have to do a range because this goes up and down. It starts at 13. Right, that's where that line starts. It's at 13 and it stops at 16. So I'm going to do from 13. I'm going to use y because I'm going up and down, and it stops at 16. Now I'm just going to do open on all of these. I'm not going to worry about less than or equal to because there's no dots at all, so it won't make a difference. But you could do them all less than or equal to if you wanted to. It won't make a difference. And as well as you could do this on Desmos and type in all your equations on Desmos and make sure when you finish that you get this graph. So if you type in all your answers, you'll know if they're right or wrong just by checking on Desmos. Lastly are the diagonals. So the rest of them all have slope and y-intercept. So let's do a reminder about that. When you're doing diagonals, you have to use the point slope form usually is what's used. So that's going to be y minus y1 equals the slope x minus x1. And when we did the project, these were all done on a separate piece of paper because it's a little more work. So 1 through 9 will be really quick, just the vertical horizontals, and then the last 6 will be a little bit of work where you have to start off with this equation on each one. So if we're going to do, let's say, line 10, let's call this number 10 right here, and you can do the work for all this on the back if you want for 10, 11, 12. Just start off with that on each one. Find the slope of line 10, so we're going to go up 2, right 1, so the slope is 2 over 1. I'm just going to write 2. And for m, put in the x minus and the y minus and the equal sign. And then the next part was just to pick a point on this line. Any point. It could be right here, 1, 1, or 2, 3, or 3, 5. It could be any of those points we can put in for x and y. I'm just going to choose 1, 1. Usually smaller numbers are easier to work with, so since it goes through 1, 1, that's where it starts. I'm going to put 1 for y and 1 for x. Okay. And we can do a little bit of work. Distribute on the right, you'll get 2x minus 2. And then add 1 to both sides, and you'll get y equals 2x minus 1. Okay. So that's the equation for number 10. Okay. Now, we already knew the slope was going to be 2. How come this is negative 1? Why is the y-intercept negative 1? So the reason we're doing it this way is that, well, we could do it on this problem. If you took a ruler and you just imagined this line continuing and finding out where does it cross the y-axis, you would find out it crosses right here at negative 1. Okay? It's just that the line doesn't go all the way through the y-axis, so you can't easily see that. But that's what this negative 1 means, that if we continue the line, that's where it would cross at negative 1. Okay. So let's go to, what's this, 10, and write that in. 10 is y equals 2x minus 1. And the domain is going to be from, it starts at 1, and it stops at 6. So you can see this line, this diagonal, is between 1 and 6. Okay. And you have to do that for each diagonal. Now, you might remember I said it's okay to use family of graphs. So if you can look at 10 and 11 and say, well, that's basically the same line. So if 10 is 2x, 11 is going to be negative 2x because they're symmetrical. They're, almost the same, just a mirror image. And, you can use that as well. But the y-intercept, you're going to have to see, well, what if you extended, this line and they went all the way up? Where would it end up crossing? What's the y-intercept here? It's a little more difficult, and that's why we want to use the formula as opposed to trying to estimate by looking at it. Well, where would that be? Is that 25? Is it 26? Is it 24? Maybe it's a fraction. Hard to tell. So instead, use the formula, and then when you get the number, it should match up. It's like, okay, that makes sense. It's 20, 24, 25, or 26. It should come out to one of those numbers when you find the y-intercept for 11. Okay. Same thing for 12. 12, you can kind of estimate, like the slope looks like it's 1, negative 1, so you can picture this line continuing here, here, and it looks like the y-intercept for 12 will be 16. So that's a little bit easier to get. You can say, okay, that's the slope of negative 1, y-intercept of 16, so y equals negative x plus 16, and then just figure out the domain. Okay. All right, so that's just a little review. Ideally, of course, by next week, I should be able to give you something like this. I think I will, actually, as one of the questions on your test. Will just be one of these, and you won't be able to use a computer or anything, but you should be able to figure out the lines, the slopes, the domains, and then for the verticals, the ranges where you use Y instead of X. You should be able to do that all in about, I think this whole thing should take about 10 minutes or less. Okay? So be thinking along those lines. Make sure you understand how to do it on your own. Don't just look at somebody else's and say, oh, how'd you get that? I don't know how to do it, and then copy it down, and then next week on your last test, you're clueless on how to do it on your own. Spend the time. We have time. We've got a whole period. Okay? And then you'll know how to do it. Okay? Use Desmos just to check. So go ahead and work on that. Work on finishing or checking last night's homework. Have both last night's and the night before, 48 and 49 on your desk, and I'll come around and check those right now.